welcome to Desk Lady Ada.
Hey everybody, and welcome to a Sunday evening Desk Lady Ada. I got some hot chocolate in my awesome Adafruit mug, and tonight I thought we would do some really quick but still extremely useful testing of the Raspberry Pi Zero Gpio. This is part of the series of videos we're doing with Hackaday on Raspberry Pi Zero projects and the kind of stuff that you can do with a Raspberry Pi Zero. And the reason we're doing this, Mr. Lady Ada.
Because it's Superb Owl Day.
Okay.
No, the reason that we're doing this is because you're giving away 10 Raspberry Pi Zeros because there's none in the world, so we saved 10, and we're doing this with Hackaday. And let's go over some of the details.
Okay.
So first up, Lady Ada, if someone just wanted to know briefly what a Raspberry Pi Zero, what is it?
A Raspberry Pi Zero is a $5 single-board Linux computer. It's basically a miniaturized version of the Raspberry Pi A+ or B+. It's got a BCM 2835 ARM v6 processor in it, running at about 700 megahertz. It's got I think like half a gig of RAM or a gig of RAM. I can never remember. I think it's a half a gig. It has a USB power and a USB port that can act like a device or client. It has HDMI output. It has composite output. It has a 40-pin Gpio connector with tons of GPIO, some PWM outputs that can also be used for audio, I2S, SPI, I2C. It's got a flash storage capability. It's really, really small. It can do a lot. And basically it's like a little miniature Linux computer that you can fit in your mouth. It's so small. And you can do so much with it. And so we're doing these videos to show you the kind of projects that you can do for this contest. This contest is the PiZero, Pi A to Zero hack contest. What is it? Adafruit PiZero contest.
That's right.
Says on my computer. You have until March 14th to come up with an awesome project that can use the Raspberry Pi Zero. You don't have to have one to enter the contest. Design something, draw it up, sketch it out, prototype, model, do anything. You can prototype it with a Raspberry Pi B+ or 2 or a different Linux computer or prototype it on your desktop. It doesn't matter. You just have to come up with an interesting idea that would use a Pi Zero. And halfway through the contest on February 25th, the top 10 most interesting and most well thought out and documented projects on Hackaday.io will win one of 10 Pi Zeros.
That's right. And already there's been, I think, over like 50 entries, and you can see to get ideas. And we've been doling out the ideas every single week since it started. It's now, I think, going into like basically week 2. But that's the overview. Pi Zeros in short supply worldwide. However, you can win them just by coming up with ideas, and Lady Ada will give them to you. Zoom.
Me, an AdaBot.
Delivered by drones.
The little drones. Okay. So yeah, this is a perfect time. We're going to do a bunch of videos. This is our 5th video of the series. We'll do a couple more after this.
What are you going to show up tonight, Lady Ada?
Tonight we're just going to do some basic GPIO stuff because some people asked last night about GPIO twiddling. We did a mega hour-plus long video last night about all sorts of ways to get small displays on it, and the one before that was just basic video output, and we also did one on distributions, and we also did a hardware overview. So I think we'll do one on sound next because audio output, that's kind of interesting, and then people have requests, or I'll just come up with something of my own. Maybe we'll do an Adafruit.io one. This one is basic GPIO. I'm going to cross this off my list because I'm doing this one today. Maybe we'll do one on analog digital inputs and outputs if you want to do that.
Okay. What do you want to go to first?
Let's just go to, can I go to the computer and I'll just, I'll noodle around the computer.
Yeah.
Okay, thank you. So this is the contest page, just in case you're wondering. So Google for Adafruit Pi Zero contest. It's Hackaday on Hackaday.io, so you document your project. And the final, sorry, I keep forgetting to mention, you can win the one of 10 Raspberry Pi Zeros, but then the grand prize is one of $300 gift certificates to the Hackaday store. So yes, you have quite a lot, and then you can submit your project. You have over a month still to enter the contest, and you still have a couple weeks to win the Pi Zero. So today we're going to be talking about GPIO on the Pi Zero. So actually, let's look at this photo. This photo is actually kind of nice. So as you can see in this photo, there's these strip of pins here. There's nothing soldered to them, which actually is really nice. It's very flexible. You can kind of do anything you want with these GPIO pins. You can solder header to them or wire them directly to a breadboard or whatever you want. These pins are the same GPIO pins as on the Pi B+, the Pi 2. So if you would like to use these for your project, it's one of the really big benefits of the Raspberry Pi is that you get a huge amount of GPIOs. Some single-board Linux computers have 1.8 volt GPIOs, but these are 3.3 volts, so they're very easy to integrate to pretty much every device and every sensor these days is 3.3 volt logic. So the pinout for this, I like to use the elinux.org pinout. This has a lot of documentation for all the pins. This is the original Raspberry Pi pinout. If you're referring to older tutorials for the Pi 1, it might only have a 26-pin header, which is shown here. The Raspberry Pi Zero has the 40-pin header, which the first 26 are the same, and then there's extra pins down here. So you get to basically, you can still use any project that is from the Pi 1, you can redo for the PiZero. And this is the pinout. So you've got 5 volts out, and this is straight 5 volts direct from the USB power input. There's a 3.3 volt regulated output. You could probably draw about 100 milliamps out of that, or so, depending on what your PiZero is doing. Ground, there's GPIOs. And the GPIOs are labeled, 2, 3, 4, 17, 27. These are the BCM names, which we'll talk about in a bit. There's also special usage, like these 2 pins are GPIO 14 and 15, but by default they're used as the console cable RX and TX. You don't want to use these pins. And then these pins for I2C, you can turn that on and enable I2C. These pins are for SPI. If you enable hardware SPI, like these purple pins aren't available. If you enable hardware I2C, these blue pins aren't available, but that still leaves you 4, 18, 17, 27, 22, 23, 24, 25. So you get like still 8 pins, and you can still use these, if you don't turn on the hardware I2C or SPI support. But since you have the B+, you actually get, it says model A+, B+, and B2, but really it's also the 0, just they haven't updated this since. And this, you get those same pins that you had before, but now you have some more pins down here. And in particular, you get, GPIO 0 and 1 are the identification pins, so skip those. You also get GPIO 5, 6, 13, 22, 19, 16, 20, and 21. And you can actually get another, looks like there's another chip enable an SPI port down here. You also get GPIO 26. So you get quite a few. You now have like 16 to 25-ish GPIOs, depending on what you want to use. So you can plug in hats. There's like plugins that can plug into these, and maybe we'll go over some of these and just talk about the options that you got. There's a lot of hats out there. But what we want to do is actually use these as GPIO, general purpose input output. So let's do that. The easiest way to get started with GPIO is to use wiring Pi. So I've logged into my Raspberry Pi here, and you do sudo apt-get install wiring Pi, which I've already done. So it's going to say, hey, it's already installed, but you would normally install it. And now you get to use wiring Pi, which is really, oh, sorry. Did I? Hold on. Sorry, it's wiring Pi, but the command is called GPIO. I always forget this. You get this new command called GPIO, and GPIO actually lets you do a lot of stuff with the input-output pins, and it's nice. You don't actually have to use it as root. You don't have to sudo it. You can just use it from the command line, and you can start by doing GPIO-V, and that will tell you what device you have. It has a ½ gig of memory. So it's handy. This is made by Sony. Device tree is enabled, and you can use user-level GPIO access. So that's great. This was written by Gordon Henderson, so nice job. This is pretty awesome. And you can even do stuff like, I guess, power USB on and off, which if you want to like turn on and off USB devices. Let's see, GPIO help. Well, I guess it tells you the same thing. But basically you can read, write PWM clock mode, all the pins. So GPIO-G is what you actually want to use. The reason you have to use G is because you actually want to use the BCM pinouts, and the default wiring Pi pinouts don't match the, whoa, hold on. Looking at TFTs. There you go, that's what I wanted. You want to use these, pinouts. So let's say I want to turn on and off GPIO 4. So let's go to the, can we go to quad view, I guess?
Yeah, when do you want to answer some questions?
Yeah, sure.
Well, let's go to quad cam. All right. First question is, have you seen that software package Mirror? You know the thing, I think that's a Pi thing that does mirrors.
I haven't.
Okay.
But it sounds cool.
Okay. Well, someone was wondering if it ran, if the PiZero can run it. We'd have to look it up, maybe. And then the next question is, have you ever installed AIML on any of the Pis, AIML, such as Pi AIML?
I have never heard of that.
Okay.
Yeah.
Next up, I have a question for Zero. What size screens can you use, or how small can you go? Oh, excellent question. We went
did a
over
video
this
last night.
There's an entire hour-long video from last night that we went over.
Yeah, you can use displays as small as like 1.3-inch OLEDs or smaller up to gigantic HDMI displays.
Okay.
Okay, so let's start by, we're going to wire up to GPIO 4. So I have this PiZero plugged into a T-cobbler. It just makes it a little easier for me to get to the GPIO pins. If you want, you can just solder directly to these pads. You don't need to use a cobbler, just whatever you want to use is fine. This just makes it a lot easier for me to debug and do wiring because I have all the pin labels on here, so I don't have to constantly count like pin 1, 2, 3, 4, 5, 6, 7. So let's control GPIO 4. So let's bring that out here. Let me get a resistor for my LED. This is 560 ohm resistor, that's good. Okay. So this actually is lit a little dimly. There must be some sort of pull-up on here already, but let's, I don't think pin 4 is already being used. So let's do GPIO-G and then mode pin 4 and then output. So actually that turned it off. And then I guess it was an input with a pull-up. That's why it was lit up. And then we can do write 4 and then 1, and that'll light it up. And write 4, 0, and that'll turn it off. So that's actually how easy it is to do GPIO control. It's pretty straightforward. So next up, let's, you can actually write a shell script if you want. So let's write a shell script. User bin, sorry, it's not user bin, it's bin bash. And then I have to remember the thing for, so GPIO, G mode for out, for I in sequence. Oh shoot, this is not visible. Sorry. There you go.
What's up? What are you?
I didn't, my screen wasn't visible. No, don't stop expanding. That's good. Okay, for I in seq 110, so we'll just basically blink the LED 10 times. Do GPIO G write for 1, and then sleep 1, so sleep for 1 second. GPIO G write for 0, sleep 1, done. Very basic shell script, just shows like you can do command line control of the GPIO. Save this, and then command X blinky, and 1 blinky, and then you've got blinky. So that's it. Shell command blinky. You can also wire up a button and use a button as an input. So let's do that. We'll do a button with a pull up. So actually, let's rearrange some things. Go here, like so, and then so when you push the button down, it will connect to ground, and then let's use pin 22. Why not? Okay, so now I've got a button with a little pull-up resistor, and the other side's ground. Make sure Blinky still works. Okay, we got Blinky. So now let's do GPIO reading. So GPIO G mode 22 in, GPIO G read 22. Sorry, and spell it right. So it says 1, that's because it's pulled high. When I press the button and I run it again, it says 0. So that's pretty much it. In a loop, you can use interrupts also, but this is just a very easy way to, in a loop, you can and wait for the button to be pressed, and then it will return 1 or 0, and you know whether it's high or low. So that's pretty simple. That's pretty straightforward. There's also PWMs. There's no analog inputs on the Raspberry Pi, so you will have to use an adapter chip. Tony Didi actually did a great video a couple days ago on analog digital conversion with a DIP chip to read analog inputs onto a Pi through an MCP 3008 or 3002. Those are very low-cost, simple analog digital converter chips. Check out that video. I don't need to cover it because you already did a great job. So I'll just cover digital inputs and outputs. You can go watch that video after this. If you want to have PWM outputs, you need to go to one of the PWM supporting pins. Pin 18 and 19 are 2 of them. Oh, did I just do something to my Pi? Hello? Nope. Okay. GPIO G mode 18 and then PWM. And then PWM 100, pin 18, 100. It'll make it a little bright, and then 1000 is really bright, and then 10 is really dim. So dim, brighter, brightest. So you do have PWM control. You can control a little bit you can control, this is the pulse width out of 1000. You can also control the frequency of the PWM as well, but I'll leave that for you if you need it. So next up, I just want to show quickly how to use RPi GPIO. So I'm going to quickly look up the sounds. Make sure I get the right command for this. We have a lovely little tutorial. So you want to make sure you have the Raspberry Pi module GPIO installed. So sudo apt-get install python dev python RPi GPIO. I already have this in place, but if you install it, just make sure you go through and install it. And now there's actually a new GPIO library called PiZero, but I haven't had a chance to check it out. So in the meantime, I'm just going to show you the old style, which works quite well anyways. And then let's do blinky.py. So it's sorry, haven't written it yet. Got to write it. Blinky.py, user bin and Python. Hold on. There you go. From time import sleep import our Gpio as Gpio. And then you have to do a couple small things just to get everything ready. Gpio set mode Gpio BCM. This again tells it to use the BCM pinout naming. So pin 4 is the pin 4 that's labeled on the cobbler and also on that eLinux site. Again, there's like different numberings, and just stick with BCM numbering because that's like the most common one. I recommend going with that. Gpio setup, and then I have this connected to 18. Actually, I'll go back to 4. To gpio.out while true. Gpio output for it's gpio.high time. Oh, sorry. Sleep 1. So that's pretty much it. I think that's correct. Let me rewire this to pin 4 as it was. And then, I don't need to do that. Sudo Python, let's see if I get this right. So yeah, blinking. So that's another way to blink. You can blink through Python instead of through shell script. Oh, it's annoying because this warning is because I was messing around with that pin before with the GPIO wiring Pi code. All right, so next step, you can turn on off stuff. Let's do nano button.py. And so now we'll write, oh, actually I already have one. Let's do button tiger. Yeah, there you go. Oh.
I got rid of that thing.
Yeah, and it's gonna happen eventually, but not yet. So I'll expand up.
What's gonna happen eventually?
I will use the video output, but it's gonna take me a few more minutes.
Okay.
So we'll pop back to it.
Just let me know when.
I will let you know.
Do you want to answer a question while we're doing
Sure,
this?
let's do a
What
question.
about real-time handling of interrupts? I understand that Linux isn't a real-type OS, but how far of is it?
You can actually use interrupts pretty easily. I didn't get a demo ready, but maybe at the end I'll quickly look it up and see if I can get interrupts going. You can definitely do interrupts with Python through either RPyGpio or similar library. You basically set up a callback. Again, yeah, it's not going to be like to the clock cycle interrupts, but you don't have to poll. But I'm going to show a polling example because most people are familiar with polling, and it's easy to get started.
Okay.
So for this demo, time port sleep, port PiGpio as GPIO, and then we'll do the same thing this time for a button, for an input. Set the mode to BCM. Set up that pin to be a GPIO input. And this is again, this is not the most elegant, but it does work. This is just a polling setup. If the input is false, that means it's low because you press to short it to ground. And then this is really simple debouncing. Basically just delay, because we don't have to have it be super fast. And then when you press the button, it prints out that the button was pressed. Okay, so that's easy, you know that works. And now what you can do is have it do stuff when the button is pressed. So it's really easy in Python. I mean, you can do it in shell script as well. It's very easy to have it do something else. So for example, I already got ready a command that it can run. So hold on, let me go back to fewer lines so you can see it. Call OS system. There's also a process, sub-process management, entire thing. And timeout 3 just means run for 3 seconds. The Hello Tiger demo on the video screen. So can I go back to quad view?
Yeah.
So this time when you press the button, when it detects it, it will...
terminal down.
Yeah, I'll have to move this down.
Yeah.
Okay, so now when I run it... Oh, sorry. When I press the button... Oops. Oh, hold on. Let's put one instead of double. Try again. We get a tiger. It's just one of the demos that you can do. I mean, you can run any program in the world. You can have it connect to an internet site. You can have it send or receive files. You can have it play audio. You can have it play video. This is just one of the demos that comes with the Pi as a little spinning tiger animation. So it just shows like whenever you press the button.
Press the button, a tiger.
You get tiger.
Tiger image plays.
Tiger goes tiger.
That's a project itself that could be on Hackaday.
This is like instant tiger. But now you have the way to control GPIOs. It could set off a relay. That relay could like turn on a strobe machine. You could have a tiger rave. It could play some dubstep. I mean, like the world is your oyster with GPIO. So that's my basic GPIO demo. Maybe I can take questions and I'll look up RPi GPIO interrupts because I don't have an example code, but I will look it up. Any questions?
Yeah, let's go. Apparently, reminder, there is a real-time operating system that can be added to the Linux kernel. So I guess that's a response to the other question that someone's helping out with.
Yes, just Raspbian isn't, and that's probably what you're using. Yeah, I mean, look, you can write code for the chip itself if you really want super high speed. I don't know if there's a lot of, I mean, it's really, really fast. For a lot of the things, unless you're doing absolute motor control by like ticking each coil, you can, like a gigahertz is fast. You can do things pretty much whenever you want. It's almost instantaneous. All right, so let me see. It looks like it's called add event detect. So let's try, I'll try this. int.python. And then copy and paste this. Okay, and then GPIO add event detect. Okay. So channel. I don't know what channel is though. So, oh, that's the pin number. Okay, so wait for edge. No, I want to event. Okay, so I can run GPIO add event detect 22 GPIO falling. And then I guess that's not really a callback. Oh, I can set a callback. So GPIO falling, and then callback equals my callback. And then okay. I don't know, let's try this. Yeah, so you can do interrupts that way. Seems to work just fine. So if you wanted to change it, so here, you have some code that does stuff here. Do stuff. And then you basically display a tiger when the button is pressed through a callback, you can put that up here. These are these spaces. So this time with callbacks. Tiger. Rawr. All right, so yeah, you can do interrupt. And tiger away. All right, any other questions? Concerns? Requests for different spitting animals?
No, that's pretty much it.
Okay.
Okay, and you're right at the 30-minute mark. So
Great.
fantastic. All right.
A great little demo. Okay, so we covered inputs, outputs. You get PWM if you want, interrupts if you want through Python. I don't know how you would do it through Shell. I mean, there might be a way to do it by like doing weird pipe stuff, but honestly, like this Python callback system works really well. And yeah, this is all on the SourceForge repo for Raspberry Gpio Python. So I don't know if this is the official repo for it, but it has a lot of information on how to use the GPIO setup. You know, they basically talk about, you can remove the event detect, you can have it keep track of your debouncing for you, all good stuff. More tigers.
Okay, well, thanks everyone. This was Desk of Lady Ada, special Hackaday edition. We'll be here throughout the week. We'll probably do a couple more broadcasts. Worth noting, you can go to the hackaday.io site and be one of the people who enters in your ideas. Yeah. And this goes all the way to the end of February, basically. So your chance to win just with an idea, a PiZero. This week is Ask an Engineer, 8 p.m. Eastern Time.
Yep.
On Wednesday. Show and Tell.
7:30.
7:30.
Wearable Wednesdays.
Yeah.
2 p.m.
Yep.
3D Hangouts, 3 p.m. Thursday.
Yep.
And, of course, we'll be doing broadcasts all week. Tony DeCole will probably be doing a broadcast.
Yeah, we got a bunch of stuff going on.
So you have no excuse not to enter this contest.
That's right.
And you can win free stuff. No purchase necessary.
Yeah. And if you like to support this type of programming online, when I mean programming, I mean programming and programming, pick up a kit from Adafruit. Your orders support Adafruit. If you like open source hardware companies that don't need or take funding or loans or venture capital.
It's funny. It doesn't do debouncing, so sometimes it plays the tiger twice.
That's fine.
Yeah, because it doesn't debounce.
Bonk, bonk.
Got to add that in.
And one question that someone just had.
Yep. I'm here.
Tom said...
Tom. What's up, Tom?
Is it okay to show off project stuff on the show and tell? Absolutely.
Yeah.
See you Wednesday at 7:30.
Sure. You get advice, hints, laud approvals.
Yeah. We're just running the contest as far as giving the pies away and
this is
generating ideas. We're not judges, but I would say it probably helps to show your ideas.
Yeah. They'll probably be watching, and maybe they'll be inspired. They'll understand your project better.
Yeah. Just stop by google.com/plus Adafruit around 7:30, and you'll see a link to join the show and tell.
Actually, you know, it'd be really handy, like a little device. It's just instant kittens, where if you press the button, it just like displays some like cute animal.
How's that different than a cell phone right now?
Well, I mean, it's a single-purpose device.
Oh, in addition to to checking text messages and looking at cats. This would just look at cats.
Just look at cats. Okay. All right. Well, thanks, everybody. It was a fun little video. And if you have requests for other videos you'd like us to cover, things you want to learn about, you see people ask about interrupts, I will do a little interrupt demo. Whatever you want to learn for your project to make your project the bestest project ever, ask away. We will try to cover it in a future video. We're going to have another 5 videos, so you have plenty of time.
All right, and check out hackaday.io for not only the contest, but the additional things that you can win in addition to the PiZeros.
Yes.
There's all sorts of stuff. Okay, folks, that's it.
Bye.
Bye-bye.